Okay, number 3, we're asked to find an antiderivative and then to check the answer using differentiation. So we're given 3x squared natural log of 4x. Now, we have our 5 basic integration formulas. We can try a u substitution. Nothing's going to quite work out. So we'll try integration by parts. So the idea is we want to let u be a complicated thing so that when we take its derivative it becomes easier. We'll let u be natural log of 4x. The dv then is everything else. So to find my du, I take the derivative. The derivative of the natural log of 4x is 1 over 4x times the derivative of 4x, which is 4 dx. So I get my du is 1 over x dx. To get my v, I integrate 3x squared dx and get my v then is x cubed. So the integral 3x squared natural log 4x dx is uv minus the integral of v du. U times v is x cubed natural log 4x minus the integral v du, x cubed 1 over x dx. So I get x cubed natural log 4x minus the integral of x squared dx. So we've taken an integral that we didn't know how to do, and we're left with an integral that we know how to do. And so I get x cubed natural log 4x minus 1/3 x cubed plus c. How do we check this? Well, we take the derivative. Since I used integration by parts to evaluate this integral, I'm going to need to use the product rule when I take the derivative. So product rule on the first term, the derivative of the first factor times the second plus the first times the derivative of the second minus the derivative of 1/3 x cubed is 3x squared over 3 x squared, and the derivative of the constant then is 0. So I get 3x squared natural log 4x plus, I take the derivative of this, I get x cubed times the derivative of the natural log of 4x, we saw that earlier, 1 over 4x times 4. I get 3x squared natural log 4x plus x squared minus x squared. So I get 3x squared natural log 4x, and just like magic, that's the integrand. So that checks it. And finally, our last problem on the checkpoint quiz. We're asked to compute this definite integral. So once again, we could try a basic u substitution. It's not going to fit one of the formulas we know and love, so we're going to have to make choices for u and dv. And remember the rule of thumb, we want to choose u so that when we take the derivative we get a simpler function. So in this case we'll let u be x, so the du is 1 dx. The dv here is e to the x over 3 dx, because that's everything that's left over. I integrate to get the v. I think of this as 1/3 x, so the v is going to be 3e to the x over 3. uv minus the integral v du. U times v is x times this, so I get 3x e to the x over 3 minus the integral of v du. 3e to the x over 3 dx. Sure enough, I can evaluate this integral. I get 3xe to the x over 3 minus 9e to the x over 3 plus c. So I go back, I actually have a definite integral. So the integral from 0 to 1, xe to the x over 3 dx equals 3xe to the x over 3 minus 9e to the x over 3, evaluated from 0 to 1. I substitute 1 into this. I get 3 times 1 times e to the 1/3. So 3e to the 1/3 minus 9e to the 1/3. I subtract off, I substitute in x equals 0. The first term zeroes out, but the second term I get 9e to the 0, which is just 1. So when the dust settles, I get negative 6 e to the 1/3 plus 9. And that's our final answer. And that'll do it for checkpoint 6.